Chapter 4: Digital Transmission. Digital to digital conversion. In this section, we see how we can represent digital data by using data signals. The conversion involves three techniques: line coding, block coding, and scrambling. Line coding is always needed. Block coding and scrambling may or may not be needed. Line coding and decoding วิธีการแปลงบิตของข้อมูลนะครับ Line coding is a process of converting digital data to digital signal. You can see in this sender send the digital data to the encoder, and the encoder send the digital signal transmission in the link to the decoder, and the decoder converting to digital data to receiver. Signal element versus data element. You can see in this picture, data element is one signal element. One data element per one signal element. It means R equal 1. Or B, one data element per two signal element. It means R equal a half of 1. Two data element per signal per one signal element. R equal 2. Four data elements per three signal element are equal 4 and 3. Effect of lack of synchronization. A send and a send is digital data, but and the receive the signal and is had a little bit of mistake in this signal in this picture. So we decided to use line coding scheme. Line coding has files. One, unipolar, non-return zero. Polar, non-return to zero, return to zero, and biphase Manchester and diffusion Manchester. And bipolar, AMI, pseudo-ternary, multi-level, and multi-transition. So one, unipolar, non-return zero scheme. It's used only one voltage level. Like you see in the picture, the bit one is one voltage, and bit zero is a zero voltage. It's not. This is line coding we didn't use because it have a lot of mistake and useless. Polar non NRCL and NRCI scheme. You see in this picture, in NRCL, the level of the voltage determines the value of the bit. In the NRCI, the inversion of the lag of induction determines the value of the bits. NRCL and NRCI both have an average signal rate of N of 2 BD. Yeah, and NRC both have a DC component problem. So, polar RC scheme. The bit data is mean 1 voltage and is B positive data, and the bit data is 0. The voltage is mean minus. Polar biphase Manchester and differential Manchester scheme. The Manchester and differential Manchester encoding. The transition at the middle of the bit is used for synchronization. The minimum bandwidth of Manchester and differential Manchester is 2 times of that NRC. You can see in this picture. In the bipolar encoding, we use three labels: positive, zero, and negative. And you can see in this picture, multi-level to be one key screen. In Scream, the pattern on M data element is encoded as the pattern of N signal element, which to power M is less than L power N. So you can see in this picture. Multi-transition MLT3 Scream. The multi-line transition tree level. If the next bit is 0, is there no transition? And if next bit is 1, and the current level is not 0, the next level is 0. If the next bit is 1 and the current level is 0, the next level opposite the last non-zero level. Somebody apply the current screen. So you can see this bipolar, costly, no self-synchronization, polar, in NRC, both, no self-synchronization. Biphase is self-synchronization, but high bandwidth. Bipolar, no self-synchronization. Block coding concept. A block coding is normally referred to MB and NB encoding. It replaces each M-bit group with an N-bit group. So you can see in this division of stream into M-bit group, it into substitution and combining N-bit group in the stream. Using block coding 4B and 5B with NRC line coding scheme, and you can see in this picture table 4.2. This NRC synchronization, the block coding stream does not have three consecutive zero. So you can see MMI used with scrambling, a 5-bit stream length, block coding, NRC line coding, DC problem, bipolar synchronization forbidden for long distance communication. Scrambling provides synchronization without increasing the number of bits. Break NMI rule of encoding along sequence of zero. BXCS and HDB3 is can fix that. Analog to digital conversion. We have seen the chapter 3 that digital signal is superior to an analog signal, and the tendency today is to change analog signal to the digital data, and in this section we describe two techniques: pulse code modulation and delta modulation. Component PCM encoder ตามชื่อเป็นเทคนิคสำคัญในการแปลงอนาล็อกเป็นสัญญาณดิจิตอลนะ it's a it's an important technique to change analog to the digital. Three different sampling methods for PCM. So you can see ideal sampling, natural sampling, and flap-top sampling. Nyquist sampling rate for low pass and the band pass signal. According to Nyquist system, quantization and encoding of simple signal. Process of data modulation. The simplest data modulation PCM, the value of signal amplitude each sample. DM, the change from previous sample. So you can see the graph N is have a lot of overload noise and granular noise. The granular noise is less, but the overload noise is be huge.